All right, so today we're talking about molarity and replacement reactions. And when we deal with molarity, it's been a while since we've talked about molarity. But remember that molarity represents what? Moles over liters. Very good. So when we talk about the steps for stoichiometry, step one, write a balanced equation. That's always going to be consistent. You're always going to have to write a balanced equation. Step two, change what's given in the moles. So when we talk about molarity, and again, big M represents moles per liter. This we can change into moles, but what else do we need to get molarity to moles? That's a good question. What is it? Yeah, you need a volume. So we're always going to have a volume, or I'll ask you about a volume. So this is really important, and it's not in the notes. I have no idea why I didn't put it in the notes, but you need to write this down. If you know both the volume and the molarity, let's call that, always start with the volume. Okay? No ifs, ands, or buts. If you know both the volume and the molarity, always, always, always start with the volume. Now, if you're given a molarity, but it's asking you for volume, you can't start with the volume because that's what the question's asking for. So that would be step 4. But if you're given in a problem, kind of like what we're going to do here for our first one, if you're given the volume and the molarity, always start with the volume. That would be for step 2. Okay? Questions about that? Probably will make a little more sense once we actually do a problem. But I think that's all I really wanted to say about that. Let me see if there's anything else that's pressing on that. Nope. So let's get right to the example. Okay. So let me zap that. Okay. So question or example number 7 says, in a single replacement reaction, aluminum metal replaces zinc in a zinc nitrate solution. Be careful with that wording. Doesn't mean that you have Al plus Zn plus ZnNO3. That's not what it's saying. Okay. So it's talking, or it's going through the mechanism of a single replacement reaction. And that's pretty typical how some questions are worded. So don't just write down everything that you see. Read the question, understand what it's asking. And then the question says, calculate the mass in milligrams of zinc metal produced in this reaction when 200 milliliters of a 0.44 molar solution of zinc nitrate is reacted with the aluminum metal. So it goes ahead and repeats it again. So let's start off with step 1. Sorry, let's do that. So in a single replacement reaction, aluminum metal replaces zinc in a zinc nitrate solution. So here's what the mechanism is saying, and I'm not going to balance this yet. But what it's saying is aluminum is replacing zinc. So zinc is going to get kicked out, and we've worked on single replacement reactions. So what will my products be here? Zn. So we're going to have the zinc kicked out. And go ahead, what else? AlNO3. And we'll come back and, L would be nice. We'll come back and balance that here in a moment. Okay, so that's what the question's saying. That aluminum replaces zinc in a zinc nitrate solution, and it doesn't tell you, it does say, here we go. So question mark, milligrams of zinc produced, okay? But that's all it says. It doesn't say anything about the aluminum nitrate. So remember how to predict the products for single replacement, double replacement reactions. Those are going to be pretty typical. Come here. Get you down here. All right. So let's write down what else we know about the problem. So it says that we have 200 milliliters of a 0.44 of zinc nitrate. So let's go ahead and write that. 200 mils of a 0.44. Okay. And then once we have that, I don't need to look at the question anymore. All right, so step 1, write a balanced equation. Is that a balanced equation? No, not even close. Okay. So we have to remember charges. So what's the charge on zinc? Let's take a look at our periodic table. Where are you, periodic table? Okay, so remember, you always have a periodic table at your leisure here. So zinc has a +2 charge, and if you remember, if you had me, the aluminum slide, aluminum, zinc, silver, +3, +2, +1. So zinc's +2, and it only has a single charge, which is nice. So zinc is +2. So let's write that above. What's the charge on nitrate, NO3? -1. Don't forget that. So is that balanced as written? No, we need 2 of those, right? Okay. So let's move you out of the way. Actually, let's just zap you. And let's come over here to the aluminum. What's the charge on aluminum? +3, very good. So when you look at your periodic table, +3 is right there. And you always be able to have access to that. So +3, and nitrate is still -1, so we need how many? 3 of those. So that's going to look kind of choppy there. And let's get rid of that. Okay. All right. Now that we have the charges, because we have ionic compounds in here, so we have to balance the charges. Do we have the same number of atoms on both sides? No. Let me scoot this down a little. Sorry. All right. Now we got a little more room to work. Oh, come over here. All right, so how do I balance this? Start with the nitrates. Do we have the same number of nitrates on both sides? No, we have 2 there and 3 there, so we need a 2 there and 3 here. Okay, so our nitrates, NO3s, are balanced. How can I balance the rest? Put a 2 there and a 3 there. All right, there we go. Now we're cooking. Okay, so step 1, that's all step 1. So a little bit more work involved there because it didn't tell you what the products were and you had to go back to a couple units ago. All right, so do we know the volume and the molarity for this? Yes. So since we know both the volume and the molarity, we're going to start with the volume. So let's do that. So 200 milliliters. And what do I want to do to the milliliters? Good. Convert it to liters because don't forget, molarity is moles per liter. So we always want to go to the units that we're trying to cancel or trying to get rid of. So we have to change the milliliters into liters. And which one's bigger, a liter or a milliliter? And how many milliliters in a liter? 1,000. Good. Okay. And then what do we write? So we're going to put our 0.440. Now remember, molarity is written like that. You never ever put a big M in the work. Okay. So to get rid of the volume, molarity is moles divided by liters. The only time we ever write big M is like if I'm saying, okay, I've got 0.44 molarity. That's the only time you write big M. Any other time in the math, never put it in there. It's always moles per liter. All right, so that right there is step 2. And that actually is our lecture for today, right there. Okay. And that's what's different about today. Okay. So keep going on. So what do we do now? And sorry, let me write this just to put the clarification of the units there. So what was that again? Yeah, so we want to get rid of the moles of the zinc nitrate so we can go to moles of what? Zinc. So we'll put what we started with on the bottom, and we're trying to find something out about zinc, so we need to do the mole ratio for the zinc nitrate and the moles of zinc. And what numbers go there? 3 and 3, because from the balanced equation, we have both 3 and 3 here. And that again is step 3. So step 4, we want to convert to the desired unit, which if we stopped right here, we would have moles of zinc. Okay, so like if we stopped right here, that would be gone, that would be gone, that would be gone, that would be gone, that would be gone. So how do I get rid of moles of zinc and get it to milligrams? Good, so if it's not what we're looking for, move it diagonally and convert the moles of zinc to what? Grams, because that's what's on the periodic table. And zinc is 65 point something. 3.9? Good, okay. Yeah, we're getting close. Then what? How do I finish this off to get it to milligrams? Good. Very good. And which one's bigger in this case? Grams. So assign the larger of the two, the value 1. And there's 1,000 milligrams in there. Ooh. And that, again, is step 4. And make sure your calculator can get the right answer here. And if you needed to type this in, I would say 200 times 0.44. And these really don't change, so I'm not going to type that in. Times 65.39. I have 1,000 here and 1,000 here, so I'm not going to type that in either. So really, that's it. No, it should still give you the same answer. Just make sure you use your parentheses. So if you were to type everything in, okay, that should give you like 5,000 something. If you were to type everything in, then you go 200 times 0.44 times 3 times 65.39 times 1,000 divided by, open up the parentheses, 1,000 times 3. Anybody get a number? Nobody? Yeah.
5,754.32.
Love it. 5,700. What was that again?
54.
Yeah. Cool. And that is in milligrams. Okay. All right. Issues with that one? And again, this is the only thing that's new today. Everything else is the same, sadly. Let's do another one. A little bit different. Give you a second to look at that. Okay. All right. Example number 8 says 325 grams of lead is mixed with a 3.45 mole solution of iron 3 nitrate. Wow, that's fun. Calculate the volume. Ooh. Calculate the volume. In milliliters of iron 3 nitrate needed to completely react all the lead metal in this single replacement reaction. All right. So let's start off from the beginning. Lead metal is mixed with a 3.54 mole solution of iron 3 nitrate. So iron 3 nitrate. We'll come back and balance the charges here in a moment. Calculate the volume of the iron 3 nitrate needed to completely react all the lead metal in this single replacement reaction. That's all it's telling us. Okay. So really what we have is the lead and the nitrate. So the lead is kicking the iron out. And what are we going to form on the other side?
Fe plus PbNO3.
Good. So we'll have Fe plus PbNO3. Now, the nice thing is, the question doesn't say anything about the charge of the lead here. So it's up to you if you want to go +2 or +4. That's one of the viable charges that lead could be. So 2 or 4 is one of your charges. Make sure it's a legal charge. So when you're doing this, don't just go, I want lead to be a +3 charge. It doesn't have a +3, so we can't make it a +3. Actually, let me move this over a little bit. It's blocking here. Already. Maybe. So since lead can either be a +4 or +2, that's your only option. Okay. All right. So let's see here. So what do you want it to be? 2 or 3, or 2 or 4? 2. 2. Go easy here. So we'll make it a +2. Nitrate's -1. So what do we do there? Good. Okay. So that's good. Get rid of that. All right, and then come back over here. Let's look at the iron. What kind of iron is that? What's the charge on it? 3, because it has a Roman numeral 3 on it. So it can either be 2 or 3, but in this case, since I gave you the Roman numeral 3, we got to go with the +3 charge. And the nitrate's still -1. So we need how many of those? 3. Okay. All right. And let's write down what we know. So we know we have 325 grams of the lead, and we also have a 3.45 molar solution of that. The question says what? Calculate what? The volume in milligrams, I'm sorry, milliliters of the iron 3 nitrate. So we need question mark milliliters. All right, so once we have that, let me scroll this guy up. Okay, so step one, is this balanced? No. So let's go fast here. 2 and a 3 there for the nitrates, balance those out. And then lead is 3 and the iron is 2. Okay. So step one is completed. All right. Do we know both the volume and the molarity for this question? No. So we cannot start with this information. This information is not going to help us. But do we have information for the lead that can get us to moles? Yeah, anytime you have grams, grams will get you there. So start with that. So we know we have 325 grams of lead. So that's what we're going to start with. And don't freak out and say, now wait a minute, we were working with volume and molarity in the last one, but I gave you the volume. This question's asking for the volume. So whatever you have that will give you moles, start with that. And so we want to change the grams into moles. And lead is like 207 point something. 2. Thank you. And so there, that's step 2. Not as long. It's still step 2. And then we want to get rid of our moles of lead. So we'll move that diagonally. And we want to change that into iron nitrate, right? All right, so iron 3 nitrate, sorry. All right. And what numbers go in front of there?
30.
What is it? So we're going to have a 2 here, right? Right? And then the lead will be a 3. Okay, since we're going with iron nitrate and the lead. All right, now, here's the interesting thing, and that's step 3, of course. Now, here's the interesting thing. How in the world are we going to get a volume when if we stopped right here, we would have moles of iron 3 nitrate. Keep in mind that when you're looking at molarity, molarity is moles per liter. Also, keep in mind that whenever you're looking at, say, these things right here, like I have 1 mole of lead, which equals 207.2 grams. I can go the other way and say that if I had 207.2 grams of lead, I have 1 mole. So these things are equivalent to each other. These are always equivalent to each other whenever we do these conversions. So we can also say that if I had, say, a 3 molar solution, that would mean that I have 3 moles for every liter. Or that for every liter of this solution, I have 3 moles. So it's possible / legal to flip these. So what I want to do in this case is, if it's not the unit that I'm looking for, I definitely move it diagonally. That's not going to change. That's always going to be a rule. Okay. But what number will I put in front of that mole value for this problem? 3.45. So I'm going to put 3.45 here. Actually, let's use a different color. 3.45, and what goes on top? 1 liter. Okay. So what this is saying is, again, it's a conversion. So for every 3.45 moles in that liter, that's a 3.45 molar solution. So it's legal to flip that and invert it. Now, once we have that, that's nice because the moles of the iron nitrate go away. Now we're left with liters of iron nitrate, and all we have to do to convert this to milliliters is what? Yeah, keep doing what we've been doing. So if it's not the unit you're looking for, slide it diagonally. What are we going to put on top? Milliliters. And which one's bigger? And there we go. Okay. So the really interesting component was this, where that's equal to our 3.45 molar solution. But it's inverted because, again, if it's not the unit you're looking for, move that thing diagonally so we can cancel that unit out. We have to do that. All right, let's get rid of that clutter. Maybe. All right, so anybody get a number here? Let me type this in.
30.30?
303?
No, 30.30.
Check that again, Hannah. Here, so we've got 325 times 2 times 1,000. I think that's everybody on the top. Divided by 207.2 times 3. See what you get this time. You may have only did 100 there.
10 to the third on the top.
10 to the third, I love it. Wait, what?
On the
This one?
Yeah, my calculator did
Okay.
10 to the third.
So you still get 30.3?
Yep.
Anybody get 303? Okay. Let me see what you did, Hannah. I'm curious. So that's where your 10th came from. All right. Anybody else?
Okay.
So, again, hopefully not too difficult. Again, just one small component, one small addition here. The homework tonight is the 4s. Do the homework. That way, when we're doing the worksheet tomorrow in class, if you have issues, hey, you're going to have some good questions, because the quiz on Thursday will cover what we did here and what we did at the beginning. So it'll be an interesting quiz. Not difficult, but just interesting. Questions? Anything I need to clarify? All right, so work on the 4s.